I want to go very quickly because the rounds are very short. I was sorry, I'm rushing through because I don't want to keep you from the very juicy part. So we are presenting a complete, as complete can be, compliance toolchain for Yocto projects. So this in the context has been produced for a project we are part of called Eclipse Oniro, or Oniro in short. It's an Eclipse Foundation project. It's Yocto based, so and it provides an all scenario platform project. It's very complex. The numbers are quite impressive. Cannot run through, but they are quite long. And everything is based on CI. So everything is CI'd. And we also needed to have a completely CI'd also compliance process. So we needed to build with the existing parts and building part that did not exist by providing a dedicated tool chain. This toolchain for compliance has been made not just by us, but for the Neupet Tech Park. People are in the room as well. And they have done much of the heavy lifting of programming. And Alberto, of course, gets the credit for the software. It's also an Eclipse Foundation project in its own right. There is a repo, and you can look at everything. It's based on already existing all the known subjects of compliance. Pathologists can code, but we have to create a dedicated new custom set of tools, also being distributed as open source. Of course, we use SPDX all across the toolchain for many things. And this is important. This is not just for this project. This is meant to be a toolchain for all Yocto-based projects, not just for this. Through this combination of tools, we have been able to complete a very lengthy process of compliance, reaching 100% of coverage of all the components. I don't want to skip, thanks to the Debian providing a lot of the information that we have already used. Here you can see very easily, very quickly the dashboard, so you can track the evolution and the status of compliance. You can also go and have many more details of the single packages. That is just for knowing what components and what license is there, but we cannot stop there. We want to go further, and we have what we call the second phase of the compliance toolchain, and we decided to go for a graph database for many technical reasons, because there are a lot of interaction and we ought to traverse the database very easily. We need to do the missing part, which is software composition analysis, dependencies analysis, and incompatibility checks. And everything must be done automatically as much as possible. So this must be entirely into the CI pipeline, which it does. So in order to do this, we need several things. Map, this is really important, map all licenses data from the source to the binary, and at file level mapping. By file level mapping, we mean every single file, including patches. Everything that goes through needs to be checksummed and tracked through in order to make sure that everything that goes inside is tracked. This information comes from many sources. We had an audit team has done a lot of work, and finally, we need to find a way to automatically, as much as possible, see if the inbound and outbound licenses are compatible with each other through automated tools. So this is in a very short time, the general description. Here an example of the relationship between components in the database. And there is the next bit, which is perhaps more interesting, and I give the floor to Alberto.
So, thank you, Carlo. And so the question is, why do we need this? So, Yocto workflow, for those of you already familiar with that, is quite simplified here. We have recipes. Recipes can map to a single upstream source component, but possibly also to different upstream components, maybe the main application, then some plugins. So you can have here many different upstream sources combined together, fetched, and together combined into a single work there in the unpack stage task of the build process. Then, yeah, there are other tasks, configure, patch, whatever, basically build. You get binaries, and binaries are combined together to form the final image. But the problem is that when it comes to upstream sources, we have upstream components that have multiple licenses inside it. Maybe we have different components with different sets of licenses. But the thing is, we have only a small subset of the binaries that we could generate from all this stuff. And the binaries, you don't know what the actual license is, especially when here you have kind of a mess. And the thing is that you risk that some dirty stuff ends up in your image. I mean, I don't know, if you have a package with a blacklisted license or an incompatible combination of licenses, you may have in your final images something that is not compliant. And this is something we need to avoid. So the thing that we have to do is to follow a process. So to find out the relationship with third-party upstream code, so the inbound code, then we need to find under which license the inbound upstream software is, therefore the inbound license, and found if there is a possible combination of that, because not all combinations are allowed, and depending on the context they may be allowed or not, like other talks pointed out this morning. And we need to match this combination with the abound license. Is the wanted abound license compatible with the inbound licenses? And this for each artifact. We cannot do that, especially in the embedded field, at package level, because the package may contain a lot of stuff. And we need to know about the files, not the generic about the package. Here we have an example. I hope it's readable. This is GPG-ME component, the GPG made easy. It's a very small component. In our project, we found it out that we generate only 3 binaries out of it. If you look at the license, at the recipe, you find GPL, I guess, 3 or LGPL2 or something like that. But this tells us nothing, sorry, not or, but and. So the thing is that this binary, is that GPL, is that LGPL, is that something else? We don't know from what we have from source license information. So we collect in this graph database multiple sources of information. So on the yellow dots are the information coming from our audit team working on FOSology, so file level, source, license information. The purple dots are comes from Yocto metadata, and also the information about which files have been generated by to generate, that have been used to generate this binary, comes from Yocto from the create SPDX class presented before. Basically, we now have MIT, GPL2, GPL3. Sorry, GPL2 or later, or LGPL3 or later, and then we have GPL3 or later. What's the license of this file? So usually the audit team comes to us and we discuss to find out which is the license of the binary file. But this is not scalable. This is error prone. We cannot do that for every single binary file, for every release, for every snapshot of the project. This is another example. This is another binary you can generate from the same component. Here you have MIT, LGPL 2.1 or later. This is another story. Maybe it's easier here. So and we can have also more complicated, I won't go into the details here. So how can we handle that in an automated way? So the idea is to have a kind of a battle between license cards. So you put together every time two cards, and you need a set of rules to decide who wins, which card wins. And then you iterate and you look over all the possible combinations of license until only one will survive, hopefully. So to do that, we are trying to define a language to define those rules. We need to define the two license cards that are fighting against each other. We need to fight the called battlefield kind of context. Is that static linking, dynamic linking, whatever? The authority who said that, because you know the answer by the lawyers always it depends. So we need to say who said that. In this case, FSF, we kind of trust it, especially when it comes to GPL compatibility matrix. And here we are the result of the battle. We have a winner, or we have kind of invalid. So this kind of combination is not possible, because GPL2 only is not inbound compatible with Apache 2.0, while GPL2 or later may be inbound compatible with Apache 2.0 if you make it become GPL3, because GPL3 is allowed to be inbound compatible with Apache 2.0. So this is kind of an example. I don't have time to go into details. The rules in action are like here. When you have disjunctive license expression, you need to calculate the Cartesian product. So you need to have, in this case, MIT GPL2 and GPL3 fighting against each other, then MIT LGPL3 and LGPL3 and GPL3 fight against each other. You find a list of the decision, and we know that GPL3 or later is the license that prevails here at the end. And time's up, sorry. So the thing is that, how I already said, we consume data from different sources, from Fossology, from Yocto, and for now we have proof of concept. The aim is to upstream everything into the creator SPDX class in the Yocto project. And I don't think we have time for questions, but here and in the slide you find all the information to contact us. So thank you.